Hey guys, so here's a video on the fusion rates of gases. Okay, so it's not hard to imagine what the effusion rate is. It's basically how fast it effuses. So basically if you have, let's say, a helium balloon and you put it in an Earth's atmosphere, the helium's eventually going to leak out. That's because the helium has an effusion rate that's greater than the effusion rate of the gas coming into it, because the gas coming into it's heavier. I guess helium would leak out regardless, but the volume decreases. Okay, so there is a couple of equations relating, or a couple of equations relating the effusion rate of gases to their properties. So the most common one, which is the one we're going to use here, is the molecular weights of the gases. But it's also proportional to the root mean square velocities of the gases. Okay, so nothing too bad here. You have the rate of effusion over gas 1 divided by the rate of effusion over gas 2 equals the square root of the molecular weight of gas 2 and the molecular weight over the molecular weight of gas 1, and then you just take the square root of that. You should note that the 1 goes from the numerator to the denominator and vice versa for the 2, because that'll mess you up if you don't do that. Okay, so here's a question I made. Okay, so a gas X, which is just some gas, you don't know what it is, and it has an effusion rate 1.8 times faster than argon. What is the molecular weight of gas X? Okay, so let's bring our equation back and work through it a little bit. Okay, so we know the rate of effusion over gas 1. Okay, so I'm not going to read that out, but okay, so let's denote gas 1 and gas 2 as the gas is given. So let's call gas 1, let's call that the argon. And we know its molecular weight. It is somewhere around, let's just say, approximately 40 grams per mole. Okay, and then that means gas 2 has to equal X. Gas X, that's what we're trying to find. The molecular weight of gas 2. Okay, so now by using this equation, let's sub some values into it. So the rate of effusion of gas 1. What's the rate of effusion of gas 1? Well, that's not given, but let's just say it's 1 for simplicity purposes. Okay, now what's the effusion rate of gas 2, the unknown gas? Well, it doesn't say that either, but you've made up this one value for argon, which means that gas X has to effuse with a rate of 1.8. Okay, that's super. And we know this is going to equal the molecular weight of gas 2 of X, this is what we're trying to find, over top of the molecular weight of gas 1, which we know to be 40 grams per mole. And then we need to divide that and put a square root sign. Okay, so basically that's pretty much the hardest thing you have to do with these type of an equation. And now you just solve for X. So okay, let's solve for X. I'm going to change my color. I'm going to be... This is hard. I'll be yellow. Okay, so first thing I'm going to do is square everything, get rid of this square root sign, and that is going to give us a 0.3086 equals X over top of 40 grams per mole. That's not a very good line. That's a good line. Okay, so that's pretty simple, I think. And now you just do some pretty basic grade 10 algebra, and you get X is equivalent to 12.8 3 grams per mole. Okay, so that's it for effusion rates. That's all you need to know. See ya.